Hello YouTube. Today I'd like to talk to you about voltage regulation, specifically linear voltage regulation, because there is a big problem whenever you're using a linear voltage regulator that you don't have with switching, which is heat loss or heat dissipation. So in our example here, I'm going to be building a benchtop power supply for my workshop here. Currently, I am using a 500 watt computer power supply with all the taps brought out. That's what a lot of people use, but I need something a bit more flexible. Something that can go, up to 30 volts at least. So, in my design specs for my power supply, I want to get as close to 0 volts as I can manage to 30 volts. Adjustable current. I want to have 2 taps, positive and negative. And my handwriting's horrible. That's one thing you're going to have to get used to. So I want to have 0 to 30 volts, adjustable current, positive and negative supplies, and a earth ground, which I'll just show with that weird thing. And I'm going to be using a microcontroller to adjust things. So, you know those cheap Chinese things. Wow, I cannot draw a straight line. Whoop, 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 like that. You got a nice big screen here. You got a couple knobs here. I'll say this is like channel 1. The top one's voltage, and then your current, and then your voltage and your current for channel 2. And then you'll have a tap here, which I'll denote like that. Another tap here, another tap here, and then another 3 for your second negative voltage, or positive voltage. Maybe I'll put a little switch here. I don't know how I'll do that, but something that'll let me switch from positive to negative on the second channel. 1 and 2. And then LCD display. So that's what I'm going to be doing. Now, for the adjustable, the 0 to 30 volts, as you adjust your linear voltage regulators, you're going to have heat loss. So let's say I'm down to 1 volt. 1.25, because right now the one I'm using goes down to 1.25. What happens to the rest of the voltage? It gets burnt off as heat, and yeah, you can stick a big heat sink on it and a fan and be done with it, but there's got to be a better way to help mitigate some of that heat. Now, it's not perfect, you know, you're still going to have to put a heat sink on it, but it's not going to be as big. Oh. 0 to 8 amps. So, what do I have? Why this? And like I said, this isn't going to be the final. This is for my positive channel. Okay, so I've got 30 volts input here. I'm going to have to get a different transformer. The one I've got does do 30 volts. But I want something bigger that puts out more current, because I think I've got 2 amps current. So 30 volts. I am biasing an IRF 510A with a 47K and a 10K resistor. I've got a 5.1 volt Zener diode that's attached to the output of the LM350. And ignore this squiggle. For some stupid reason I drew a resistor there. Just ignore that. That looks horrible. Whatever. So the output of my 510 goes to the input of the LM350. The output, of course, you know, you got your adjustable resistor, all stuff. And the final design, this potentiometer will be gone. It'll go to a microcontroller pin. It's not going to go straight into the microcontroller pin. I've got an idea, but I've got to get some parts and prototype it before I know if that's what I'm going to do. But it's going to go into a microcontroller, which will basically take the place of this potentiometer. I'll have a linear encoder, one of those infinite turn jobs. I'll encode whatever I want, And then as it goes up, it'll adjust the current accordingly. Not current, but voltage, you know what I mean. So, what's really nice about this Zener diode here basically tracks the output of my LM350 here. So it keeps the voltage differential between input and output at a minimum. This is great. There's less heat loss, so I can get by with smaller heat sinks. Let's look at a practical example of this. So here it is. Here is my example. The case I've got here probably won't be the case I actually use. It's a Astron RS12A case. So it's a nice big chunky case. Let's see if I can actually get it all here. Yeah, it's a nice big chunky case. But yeah, you can see my puny little power supply, or my transformer here. Got a nice big cap. And I blew a fuse yesterday, so I've got some alligator clips doing something real stupid. So if we were to test what's actually going on here in the circuit, on the output here, I've got 2.1 volts. And on the input of the IRF 510, or the output of the IRF 510 going to the input of the LM350, it gets confusing. 6.5 volts. So yeah, good little voltage differential there. You see, if we probe the main output of what we're getting now, 29.5 volts. So close to the 30 that I was saying earlier. But what's real great, this is just normal, you know? Of course, I'm not drawing any current, but it's cool to the touch. And if I had bigger filter caps, I might actually hook it up to something to test it. But 15 volts on the output, 19 volts on the input. Is that maxed? 15 volts. Okay, apparently that is my ceiling. That's, with these resistor values, that's the most I can get. If I change them to more optimal resistor values, I think the one that I was using for my power supply that I built for school, which really sucks. I mean, check this thing out. Okay, so I've got 7805, 7812, 350. I've got flyback diodes on the 350, which I will put on this one. But yeah, it's just, this power supply sucked. It sucked so hard. I've got these are pass transistors for my voltage regulators to get more voltage, or more current, I mean. I think these could handle like 20 or 30 volts. They are tip 36C. So that's it. I think the next part is building up something that'll let me set my current and hooking up to a microcontroller, see how well it works. After that, it's really a matter of reversing the polarity of this and using a different voltage regulator, one that does positive, one that does negative, you know, the complementary pair stuff. I don't know how I'm going to set one to be either or. I might actually have to build 3 channels and then just one switching between the two. There's got to be a better way to do that, though. If anyone has any ideas, let me know. What I have got here is a little sample dummy load. There we go. So I've got 2 10 ohm resistors in series. I'm just going to be using one of them. And let's hook this up and see what happens. We'll measure before and after. So if I turn my voltmeter back on and get my probes, sometimes probe leads are just too long, you know. So 15.7 volts. Let's see what happens when I plug this thing in. Up. 15.7. Handles it pretty well. Let's check the lower ranges, because that's when we'll have issues. It's a 2.2. See if we can tweak this up to 3. Wow, okay. I went way past 3. Let's hook it up. So yeah, this big beefy filter cap that I've got here, it's doing a good job. Alright. So this is looking good. This is looking like a good power supply. Well, good. It's looking decent. It's looking adequate. We'll see when I'm done what it looks like. Let's just say that.